So Chapter 2, Section 1, we're looking at, first off, what linear equations are. You've probably seen these sorts of things before. No exponents, no square roots, and no fractions with x's on the bottom. Here's an equation that has an exponent of 2. That is not linear. Here's an equation that has a square root. That's not linear. Here's an equation that has exponents. And here's an equation involving fractions where there's x's on the bottom. Now all of these things that I'm showing you we will eventually be solving, but not in the first section. Let's do some solving on linear equations. The process is something you've used before. You want to do the same thing to both sides. We need to get the a's together on the same side. So if we subtract a from both sides, on the left, 2a minus a is just a. And on the right, a minus a would be 0. So the a's would subtract out on the right, leaving just a 4. We still have the 2 on the left. To get the a by itself, we need to subtract 2 from both sides. And so we've solved the equation. They get a little bit more complicated. In this one, we need to begin by multiplying using the distributive property. In this term, we'll multiply the 2 times y and the 2 times negative 3. In this term, we'll multiply the negative 6 times y and the negative 6 times negative 2. We can combine some things together on the left that are compatible. 2y minus 6y is negative 4y. Negative 6 plus 12 is positive 6. We subtract 6 from both sides and divide by the negative 4. So there are some common linear equations that we're asked to solve. Here's one where we have 2 variables in it, but we're solving for the y. To solve for the y, we need to begin by moving the 3x to the other side. If we subtract 3x from both sides, they subtract out on the left, and we're left with just the 2y. On the right, be careful because 6 minus 3x cannot be combined together. They're not compatible. So we're just left with the 6 minus 3x. If we divide both sides by 2, again be careful, it's not just the nice things that divide by 2, we got to divide everything by 2. And we're left with just 6 minus 3x divided by 2, which is okay, but there's other ways of writing that. If we split that apart into 2 fractions, the 6 over 2 can be simplified to just a 3. And so this would be the same answer. It doesn't matter which way we give it, it would work either way. Now, quadratic equations, we've seen these before. We need to do the process of factoring. Now, we practiced this in Chapter 1. 2 sets of parentheses. Begin with the x's. 2 things that multiply to give a 6 and subtract to give a 5. 6 and 1. They need to have opposite signs. Negative on the larger. When we've got 2 things that multiply together to give 0, one of them has to be 0. So we set each of these 2 equal to 0 and solve them individually. And so notice there's typically 2 answers on the quadratic equation. Sometimes the factoring can get a little bit more challenging. In this one, we need to look for things that multiply to give us a 3x squared. That would have to be a 3x and an x. And there's tons of things that multiply to give a 40. Let's organize it so that we can try each one and see does it work. again, you can just put these in there and see which ones work and which ones don't. I'm going to get straight to the point. We need these two and these two to multiply together and add to give 26. So the 2 and the 20, if they're put in there in this order, would work. Since it's a plus in front of the 40, we have the same sign on both of them, and that has to be a minus. And just like on the previous one, we set each of those equal to 0, and then solve each one of them. And there's our two answers. This one, we had a problem like it back in Chapter 1 practice. We need to split it apart, factor this, 9x squared, factored out of that, would leave us with an x plus 1. Factor this, negative 4, factored out of that, would leave us with an x plus 1. Now if you look at these two terms separated by the minus, you see that we have an x plus 1 in both of them. We can write the x plus 1 out front, and what's left is the 9x squared minus 4. And just like in the previous problem, we set each of those equal to 0 and continue to solve. Notice we have 3 answers on this one that had an exponent of 3.